migrate altogether. An increased frequency of storms will impact birds' ability to reach the breeding grounds on time, if at all. Rising temperatures have been prompting birds to begin their migration patterns either too early or too late. If they migrate too early, they may not be able to survive the climates they migrate through, but if they migrate too late, then all their good breeding grounds will have been taken. When birds lay their eggs too early or too late, the cycles of when the peak food source is there is off balance. Instead of there being an abundance of food of insects to feed the brooding mother or the hungry chicks, there's no longer enough food for the birds to go around. Global warming is projected to cause a 19 to 39% decline in ducks by 2030, and a 3 to 34-inch rise in sea level by 2100 could eliminate up to 45% of the wetlands in the U.S., eliminating much-needed breeding ground. Models of the future drought conditions in the regions due to global warming indicate significant declines in the prairie pothole wetlands, up to 91%. The prairie pothole region contains shallow depressions that fill with water in the spring. Many could then dry up due to the droughts, making them less suitable for breeding. That could lead to a 9 to 69% reduction in the abundance of duck breeding. And duck hunting has a large economic impact because of the money that hunters spend on travel, license fees, private hunting fees, and then firearms and ammunition. Critical waterfowl habitat of coastal marshes and estuaries along the Pacific coast could then be affected by sea level rise, changes in the inland precipitation patterns, and decline in the average mountain snowpack. In the Great Plains and Rocky Mountains, drought and decreases in snowpack reduce water flow in the Platte River and associated streams. Shoreline wetlands of the Great Lakes provide critical habitat for breeding and migrating waterfowl. Habitat destruction and fragmentation are currently the greatest threat toward the birds, and habitat loss is beginning to be most severe towards the poles. When the climates tend to be warmer, the breeds will begin to shift their distributions between the northern and southern poles. So again, as some of my former classmates said, the problem is not that the climate is changing, it's that it is changing way too fast for the birds to be able to adapt to it. So many will adapt, but some that won't, and the ones that won't may die out completely. Thank you.
Hi, I'm Garrett Suter, and I did my research on the effects of climate change in forests. So, according to the UN Food and Agriculture Organization's 2009 report on the world's forests, the world lost about 3% of forest area between 1990 and 2005, and the net rate of loss has declined since 2000. Deforestation is caused by exploitation of natural resources, including expanding populations, logging, biofuel production, and wildfires. Clearing forests for the production of biofuels is causing major concerns. Experts argue that it has a significant negative impact on forests without doing much to reduce greenhouse gases. Our class went to Rocky Mountain National Park in Colorado, where we took a hike and our guide showed us the trees that were affected by the mountain pine beetles. Carbon sequestration describes long-term storage of carbon dioxide or other forms of carbon to either mitigate or defer global warming and avoid dangerous climate change. The effect of decreasing rainfall in certain areas leads to possibility for more forest fires. Warmer spring and summer temperatures coupled with decreases in water availability dry out woody materials in forests and increase the risk of wildfire. Fires can also contribute to climate change since they cause rapid, large releases of carbon dioxide into the atmosphere. With an increase of dryness in the summer, we may be looking at an increased risk of forest fires. Other research suggests that the dominant tree species will shift. For example, our sugar maple tree may continue to live here, but it is not expected to thrive.
Hello, my name is Geauga, and Today I will be talking to you about climate change in our agriculture. I will be highlighting three main effects of climate change on our agriculture. The first of which is rising temperatures, which can increase crop failure and lower crop yields. The second effect that I will be talking about is the changes in precipitation, which can increase flooding and erosion. And the third effect is the difficulty with pests and weeds. So let's start with our rising temperatures. In this second demographic, you can see that increased CO2 conditions does raise plant height from 31% to 51%. So increased CO2 is a good thing for plants. However, it does have some definite downsides. I'm going to give you an example of this. You can see in this graphic right here, this is the growth range limits of corn. So you can see anything above 41 degrees Fahrenheit and everything below 95 degrees Fahrenheit is where the corn likes to live. So any changes or increases in temperatures above 95 degrees will severely limit the growth of corn. In this next slide, I'm showing you 5 cities relatively close to us that have that show graphs, projections as to how many days of the year that will be above 90 degrees. You can see this is 2010. These are how many days that are above 90 degrees. And then in the next 2 bars, you can see 2040 and 2070. And these consecutive bars are how many days above 90. So in one of these cities, Philadelphia, Pennsylvania, you can see that in 2010 there was 29 days above 90 degrees Fahrenheit. And it is projected to be almost 40 days in the next 30 years. So this has a big impact on how corn grows, and can be said that corn will definitely have a harder time growing as temperatures rise. Another effect on corn is its grain filling. So grain filling period is when a plant is successfully pollinated and starts to grow the reproductive part of the plant, namely the fruit, or in this case the corn. The plant puts most of its energy garnered by photosynthesis to grow the fruit so that it will be successful in being able to spread and start new seedlings. An increase in temperature will affect this time period in 2 significant ways. The first is that it increases the rate of grain filling, meaning that the corn will be able to use more energy in less time. However, it also decreases the duration of the filling, meaning that the plant will have less time to use that energy. This increase and decrease will balance out as long as the temperature stays below 86 degrees. So long story short, if the day is above 86 degrees, the corn yield will be lower than if it was under 86. So you can see here, this is change in maximum temperature. It's 0 change, there's no change. It's a change in tons. So tons per bushel. You can see that there's 0 change. However, as the temperature gets higher, you can see that this graph goes lower, meaning that there's less yields. This is a projection for the next 30 years, 2040 to 2059. This is an average of the temperature, and it's anywhere from 3 degrees to 5 degrees. So going back to that first slide, you can see that 3 degrees and 5 degrees has increasingly lower corn rates or corn crop yields. That is definitely a bad thing. This graph is also the same, but is using higher emission scenarios. So there you go. Another effect that climate change has is on our precipitation. Winters and springs are projected to see about 1/3 more precipitation. As you can see, we are right here. The graph from here to here is percent of change, so from 0 to being the light blue, which is down here, and the dark blue to be 50, which is like areas right here. So in Ohio, it's about from 20 to 30%, 30% more being on the left side, 20% being on the right side. This may seem like a good thing, like rain is obviously a good thing for some people who don't have as much as in California. However, it can also affect can also lead to flooding and erosion. You can see the flood magnitude and frequency from 1962 to 2011. This first graph is from 1962, the second is from 2011. The blue triangles are the changes in flood magnitude and frequency. So you can see that there is much more blue on this side of the map than there is on this side, which basically means that there's more flooding and can lead to more erosion, which will damage the crops. Another effect, or the final effect that I'll be looking at, is the increase on pests and weeds. So when you're looking at weeds, this is just one example of a weed. This is kudzu, which usually has only been growing in the south part of the country. However, as recent years, the temperature has been rising, and so therefore it has been giving more places to grow, because its temperature range usually wasn't so conducive to the cold weathers of Ohio. However, as the temperature rises, it's been able to creep slowly into the southern part and damage crops. An example of pests is the corn earworm. The corn earworm, you can see in this demographic right here. This is a scale from 1 to 24, 1 being 1 year and 24 being 24 years. The dark red is 24, blue is 1. This is out of 24 years, so if the area is dark red, that means 24 out of 24 years will be, there will be suitable conditions for earworms to live in, so all of this area is suitable for earworms all the time. However, this is from the 20th century. You can see that Ohio, I can't point to it over here, but you can see that Ohio only has blue and green, really, so it's only from 1 to 6 years the cornworm is able to grow and thrive. However, in the 21st century, it is predicted that it will be able to thrive from anywhere from 12 to 18 years, so that's a pretty big increase. So that would be like 1 out of every 4 summers here and 3 out of every 4 summers here, and that's bad for our crops. So our conclusion is that climate change has a significant effect on our agriculture. And it isn't just our agriculture that's affected, the whole world will change because of this increase in temperature. If we want to keep our agriculture in a positive state, as well as the rest of the world's, we should consider ways to keep the temperature from rising. It is important that we act now so that our next generation can live safe and healthy lives.
Hello again, I'm Kiara, and I am from Cairns, Queensland, Australia. Why that is important is that is one of the big reasons why I chose this project, because if you don't know what that is, it's right next to the Great Barrier Reef and right on the ocean. I've lived in the ocean my entire life, and so that's one of the reasons why I chose this project, but also it's such a big part of our world that it really does relate, it really should mean a lot to all of us, even if we do live near a lake and not near an ocean. It does cover 71% of the Earth's surface. So this has been the ocean has been greatly affected by climate change, resulting in events such as ocean acidification, coral bleaching, sea level rise, and damage to marine ecosystems. Now, one of the most commonly known of these is sea level rise due to melting of the ice caps, but one of the things that is less commonly known is that it's also being caused by thermal expansion. Warm water expands, taking up more room, so this has caused the sea level to rise even more. Arctic sea ice has also been melting at rapidly. It's expected that there will be no Arctic summer ice by 2030, and as you can see, this is a very skinny looking polar bear. It's because the habitat is decreasing, meaning they don't have as much land that they can live off, they can't get food as easily. So it's expected that a rise of 2 to 6 feet is predicted over the next century. The additional rises can be set off by excessive melting of the ice caps, or if they break off and go into the water. But the Arctic sea ice, if it melts, it won't affect sea level because it's on the water and it takes up about the same amount of air volume when it's a liquid as when it's a solid. Built on a direct effect of climate change, ocean acidification is also caused by greenhouse gases, mainly carbon dioxide. So due to absorbing large amounts of carbon dioxide, the ocean has become more acidic. Studies have shown that it's become 30% more acidic since the Industrial Revolution, and this is making it a lot more difficult for gill animals to breathe. The dissolved oxygen that they rely on, and it's also been found in dead zones in the ocean. Shellfish, crabs, lobsters, and corals have been finding it a lot harder to build their calcium carbonate shells, and in some places, as you can see, it's actually dissolving. So this is a shell that it can't build its calcium carbonate shell, and it's literally dissolving. Rising temperatures is causing extreme stress to marine species that are already suffering the effects of overfishing, habitat loss, and pollution due to warming waters. Species are migrating to new and different ecosystems that aren't familiar with them, so it's making it a lot harder for them to fit in and able to hunt, get food, and live. Also, rising temperatures can affect metabolism, lifestyle, and behavior of marine species, as well as being a cue for reproduction. So with these turtles, actually what happens is temperature it determines how many male or female turtles there are. So this could skew sex ratios and also threaten population survival. Okay, coral bleaching is a stress response caused when zooxanthellae, a photosynthesizing algae combined with cyanobacteria that provides food and color for the coral, leaves the coral due to inappropriate temperatures for it, and this causes coral death. Not only are coral reefs extremely beautiful and great for tourism, but they also host the most biodiversity on Earth and yield antibiotics, anti-cancer drugs, and other medicinal products, and are grazing and living areas for over millions of species. Tropical storms and hurricane activity have increased by 70% due to a 0.5 Celsius increase in temperature, and this has been causing a lot more tropical storms, especially in areas that do have reefs, and this is absolutely destroying them and breaking up things. And when it has that much life, it's really traumatic for the ecosystem and those species, and they can't live there anymore. So this is the Great Ocean Conveyor Belt. It is in charge of large-scale mixing, and it's in a 1,000-year cycle. So the cold, dense sea water sinks down to the bottom over there, and then travels around. And when it gets over here and over there, it rises to the top and becomes warmer. And then it comes around and drops off all of its warmth over here. And so that's why sometimes in Europe, even though it's at a higher latitude than over here in the United States, it is warmer because the Great Ocean Conveyor Belt releases its warmth over there, and then the cold, salty water sinks down again and begins the whole 1,000-year cycle all over again. But increased precipitation is putting more fresh water on the top, so it's the cycle isn't starting at the top of the ocean, it's just going from partway down, not by a large amount, but it's affecting it a lot. This could cause the Great Ocean Conveyor Belt to shut down, which has happened in the past, but it would cause the climate to flip-flop from warm to cold to warm again, which would cause crop failure. And also, we really need the Great Ocean Conveyor Belt to bring the oxygen-rich water down to the bottom and bring nutrients from the deep water up to the top. Otherwise, these marine ecosystems can't survive.
Hi, my name is Alex Pfeiffer, and I'm going to be talking a little bit about the Great Lakes and how ice coverage is affecting, or lack of ice coverage is affecting the Great Lakes. So, first of all, there's been an increase of temperature on Lake Superior in particular. It's been recorded that from the year 1979 to 2006, there's been an increase of 4.5 degrees Fahrenheit. Then, also, the temperature for the lakes are warming faster than the atmosphere is. So there are many fish species that live in the Great Lakes, one of them being yellow perch, yeah, exactly. Okay. Anyway, they're very common. You can eat them. People fish for them quite often. Anyway, warming temperatures of the lakes affect any fish that's in the lake because it's already adapted to that habitat. and a rapid change will cause that particular fish or aquatic species to either have to migrate or it will die out. So what it can do to the, what is this called? Perch, yes. Yellow perch is it can basically cause their eggs to be quite soft, and it can also prevent outer growth cycles. So so warmer water has less dissolved oxygen. So basically what that is when there's warm water, the particles are moving faster, therefore letting the oxygen release from the water. And then when the water is colder, the particles are not moving as much, trapping the oxygen, so that means there's less evaporation. With lower amounts of oxygen in the water, so warmer temperatures, the fish aren't able to survive, and once again they'll either have to migrate or, worst case scenario, die. So lack of oxygen in the water creates a dead zone where no aquatic life can live. So evaporation specifically is the same cycle. More heat produces more evaporation. Some climate models are depicting that by the year 2100, all the Great Lakes will have lost around 1.5 feet of water. So, moving on. Because of less ice coverage, there's going to be more evaporation. And what that means is there's going to be more evaporation year-round, more than is sustainable to aquatic life and maybe to lakes. So this graph here is showing ice coverage since 1979 to 2014, and as you can see, there's ups and downs, but the average is around 51%, and in more recent years, it has gone down. It's less ice coverage. And this next graph is basically showing the same thing, just a different graph. And the ice, as you can see, the average is slowly going down. And this is just a graph showing stress on lakes. So basically, what's going to happen is, with less ice coverage, there's going to be more evaporation. Because of this more evaporation, we're going to lose more oxygen in our lakes, causing the aquatic life not to live. We also have more intense winters because the lake gets snow from more water. So that's it.
Hello, my name is Mikhaila, and my project was on the toxicity of Lake Erie and the algae that grows on it. That was a big part of it. So just a little preface about Lake Erie. I know that we all live very close to it, so we know most about it. But it is the smallest in volume and the warmest and also the most biologically diverse of the 5 Great Lakes. And because of its small volume, is actually vulnerable to a lot of fluctuating water levels. And recently there has been a lot of industrial, recreational, and agricultural development along the basins, which affects the wildlife around there. So as I said before, I'm going to be talking about the algae on Lake Erie, and there are 2 different types of algae. There's microalgae and macroalgae, and the type that affects our lake the most is microalgae, which is the blue-green, greenish, red, and brown algae that we see, whereas macroalgae is the seaweed and kelp and the larger aquatic plants that we see on usually the ocean floor. So algae in its simple form is actually very good for the ecosystem. It is the base of many aquatic food chains, and it releases 75% of the oxygen in our atmosphere through the process of photosynthesis. But when algae gets toxic, that's when it is a great ecosystem. There are many different toxins that can be in algae. These are some of the most common ones over there. However, there are a few that are most relevant. Anatoxin affects the nervous system. Nodularin can cause liver damage and liver problems. And microcystin, which is the most common toxin in algae, can cause nausea and headaches and things that are generally just not very nice to the body. And also something that supports algae growth is the eutrophication, which we know what that is. It's basically an intense load of nutrients that get swept into a body of water. And these nutrients go to the bottom of the body of water, and aquatic plants flourish with these new nutrients. And algae starts to grow on the top layer, but when the algae grows, that means that the sunlight can't protrude through the water into the plants at the bottom. So when they decompose, they take up a lot of oxygen that can't be supplied, and over time, the ecosystem is severely oxygen depleted, which is called anoxia, or it might even die. So algae flourishes also on just underneath the water surface in the top layer of water, because that's where it's exposed to intermittent high light intensities. When it's exposed to too much high light intensity, it can die and save from when it's not exposed to that light. So it flourishes just underneath the water surface, and also when there's less turbulence in the water, which comes from decreased flows, which can come from drought or extraction for irrigation or human and livestock consumption. And this is very relevant to our lake because we have a small lake, and the top layer is very bioavailable. Also, something that supports algae growth is something called thermal stratification. And what this is there are different layers of water, and the top layer is warmer, and the bottom layer is colder. And these layers like to mix, which then creates the bottom layer, which is hot, and then vice versa. But when the top layer warms and the bottom layer stays cool, they can stop mixing. And when they stop mixing, the top layer becomes stable, which is an algae grows on it, and the bottom layer becomes oxygen depleted because it's too cold. And then there's also cold and oxygen. So something to know about Lake Erie is that something like this has actually happened before. In the 1960s, Lake Erie was actually declared dead, even though it was full of life. It was just the wrong type of life. And this was because of eutrophication, which is what is happening now. And this was from a lot of agricultural and urban and industrial development along the basin, which a lot of the pollutants, mainly phosphorus, was swept into the lakes, into the lake. And it was actually so bad that it was in both the Lorax and Dr. Seuss, if you know that book. That's why the Lorax is so bad. And to fix this problem, the Great Lakes Water Quality Agreement was created in 1972, and it was basically just to restore and maintain Lake Erie. So this is a picture of the 2011 algae bloom. The worst one that we've had actually was in 2014, but this is the most recent satellite picture. And toxic blue-green algae has been increasing since the 2000s, and in 2014 there was actually 300 square miles that were covered by toxic algae. And Toledo even had to do a water ban in August 2014 because of all the microcystin that I talked about before in the water. And it was actually a 10.5 on a previously 0 to 10 scale, where anything above 5 was considered severe. So that's indicative of how severe it was. And the cause for the 2014 bloom and why it was so bad was because we had a very dry summer, and then in the fall there were heavy rains that came in, and all the fertilizer that was on the soil couldn't incorporate into the soil, so a lot of it was just swept into the rivers, which then flowed into the lake. And this is also very prevalent in the Maumee River, because the Maumee River sinks and flows through many farmlands in Ohio and Indiana, which is where a lot of nitrogen and phosphorus come from. So there are 2 different types of pollution sources that we need to know about, because we have both of these very prevalent in Lake Erie. So there's point and non-point, and a point pollution source is usually from water use for commercial or domestic or industrial purposes, so like factory pipes is an example of that, whereas non-point sources come from agricultural use, field runoff, things like that. And this is, as I said before, the Maumee River goes through many agricultural lands, which is where a lot of the non-point sources come from, whereas the point sources come a lot from the Cuyahoga River that goes through many urban and industrial lands. So that's where
So some solutions to the phosphorus that's running into our lake is to basically just take a look at our farming practices and decide how to fix them, I guess. But the problem with that is that the farming practices we're using now are actually altered to adapt to other problems. So we kind of need to come up with new solutions that alter different problems instead of just one. Which includes the 4 R's of farming, which is to make sure that the right source is applied the right way, at the right time, and the right place. Which includes self-explanatory. It's just a general rule of qualify that farms can use. So I haven't really talked about climate change a lot in my thing, and this is where it relates, is that the Ohio State University did a study relating to Lake Erie, and they looked at climate change models to see the different phosphorus runoffs that would go into our lake. And this worked because, as I said before, there was a